Hey guys, today we will be learning about the different triangle congruence theorems. There are 5 different theorems that we could use to prove that two triangles are congruent. The very first one is SAS, the second one is AAS, the third one is ASA, the fourth one is SSS, and the fifth one, I put a space between the fourth and fifth one because these 4 are used for just proving triangles in general, but the fifth one only applies to right triangle. So that's why the fifth one we'll look at a little bit after. So first off, let's talk about SAS. So let's just say that we have a triangle, actually 2 triangles, and we're trying to prove that if they're congruent or not. So we can use SAS to prove these 2 triangles if two of the sides of the 2 triangles correspond to each other in one angle. So let's put this on here. So let's say that these 2 triangles and these 2 triangles, assuming that the 2 triangles are pointed like in the same direction. So let's say that these 2 triangles, these 2 sides and these 2 sides are congruent. And let's say that in between these 2 sides, even their angles are congruent. So we can say that SAS, or side, angle, side, and on the other triangle, the side, angle, side, are corresponding to each other. So we can say these 2 triangles are congruent by SAS. Let's look at AAS. So again, let's say there are 2 triangles, okay? And so basically now we have to see that if 2 of the angles in one side, at least one side, match. But they all have to be beside each other. Always remember for all 5 congruence theorems that the angles and sides have to be next to each other. So AAS, a good example would be that these 2 angles, let's say, are congruent, and these 2 angles are congruent, and these 2 sides are congruent. So we can say AAS. The angles and the sides are right next to each other, and we can say these 2 are congruent by AAS. Okay. Thirdly, we will look at ASA. So let's redraw our 2 triangles. And now we have to see that 2 angles and one side are equivalent in both triangles. So we can say these 2 angles are congruent to each other, and let's say these 2 sides are congruent to each other, and let's say these 2 angles are congruent to each other. And now we can see angle, side, angle, angle, side, angle. So our fourth congruence theorem is SSS. So let's redraw our 2 triangles. So for SSS to work, all 3 sides of the triangle have to be congruent to each other. So these 3 are congruent, these 3 are congruent. So we can say that they all have 3 sides of equal length, and so they are congruent by SSS. Now let's go over what we cannot do in terms of proving these triangles congruent. So back to our triangles. Let's say someone was trying to prove these 2 triangles congruent by, let's say, AAS. So what if they go like, oh, well, these 2 angles are congruent, okay, and these 2 are congruent, okay, and we can say, and they go like, these 2 are congruent, AAS. But see, this wouldn't work because the parts are not next to each other. So like for AAS to work, the side which is equivalent in both triangles needs to be here rather than here, because that would be SAA if you look at it combined together, and SAA is not a triangle congruence theorem, so we cannot use that. So the parts have to be right next to each other for the triangle angle sums to work. Okay guys, now let's prove HL. So HL, remember, only applies to right triangles. So let's draw 2 right triangles. That's our first one, and that's our second one. So Basically, HL means hypotenuse and leg. That's what it stands for. So basically, for HL to work, to prove two triangles congruent, the two hypotenuses have to be congruent, and at least one leg. Leg means side, basically. So either this or this side have to be congruent. And let's say that these two hypotenuses are congruent, and the bases are congruent. So we can prove that these two are congruent by HL. Or in other cases, let's say we have two right triangles. So let's say the two hypotenuses are congruent, and instead, rather these two sides, not the base side, are congruent. It still works because the hypotenuse is congruent and at least one of the two legs is congruent. So we can say that these two triangles are congruent by HL.